Okay, so welcome everybody. I'd like to formally welcome you to the APNIC e-learning web class. The topic that we are going to discuss for this afternoon is all about reverse DNS delegation. So with this, our aim is really to provide provide all of you with a sufficient knowledge of mainly the procedures that are involved in making reverse address mappings possible for, let's say, if you have a block, a /24 block, a /48 block if it's IPv6, coming in from your registry or from your local internet registries. How are you going to do reverse DNS delegations for that? Not just that, we also want to have a look at the idea or the basics behind reverse delegation. Why do we need it? Why do we need to perform reverse delegation? Is that really necessary? Now, coming into this course, it is somehow expected that all of you have a bit of background with DNS in general. So what is DNS? Why did we have that? So that's forward DNS. And then right now we are moving into the reverse of that, which is reverse address mapping, reverse DNS delegation. Okay, so that's what we want to achieve in this class. Now, just some administrative things also. Today is the 16th of January in 2013. The time from where I'm broadcasting this class is 2:30 in the afternoon from Brisbane in Australia. So I'm not sure where you guys are coming from. I know one of you is from Thailand, most likely. So probably I should say good morning to you. So for the rest, if I keep on referring to today as an afternoon, then you know that's because the time now here is already 2:30. Now I'd like to introduce myself. This is not me. Apparently I uploaded the previous slide. Champika, my manager, he's supposed to do this training, but I am sitting in behalf of him because he has to do another training this afternoon. So actually my name is Cheryl Hermoso. I will be your training officer for this afternoon session. So we will be together for the next 1 hour. This e-learning session lasts for 1 hour. So the initially like 45 to 50 minutes of that time we will allot for the lesson proper. And then we will allot about 10 minutes towards the end if you have any additional questions or any clarifications that you want me to repeat. Okay, so the idea is we will finish by 3:30 in the afternoon. Now, if you experience any issues towards, say, at any time during the class, if you have any trouble with the audio and video quality, please call my attention. Rather than, you can also actually go to this link, which is e-learning support in our APNIC website. However, I think the faster way is to just call my attention. So using the chat on your right, again, that is how you will communicate with me. The audio is not allowed for the participants for bandwidth issues as well. So just like we're all on the same page here, so that everyone will have good quality of e-learning here. We are disabling the audio for the participants. So the way to communicate with me is using the chat. Any questions, any reactions will have to go through the chat. Okay, just a brief reminder as well that towards the end of the class, there will be a very brief survey. Now, this survey is just to get some ideas from you guys, whether you learned something from the class, whether the topics actually is like what you expected it to be, and also if you have anything that you want to be added probably, or any other topics that you want to be discussed in the future e-learning courses. That is where you can give us your feedback. So I'd appreciate it if you can fill that up later on after the class. I will give the link towards the end. Now, with that, I think we are ready to move on and discuss about reverse DNS. First and foremost, do you have any background with DNS? Do you guys know what is DNS? So I think at this point, I'm not sure whether you have that background. Actually, we had that discussion at 10:30 this morning if you attended that module. If not, I will just give you a very rough background of everything about DNS. So just a bit of a concept behind it. I think, what do you mean by DNS? DNS stands for the domain name system. DNS is basically a mapping of one resource to another resource. So when we say resources, we are referring to number resources, such as IPv4 and IPv6 addresses. Another type of resource can be the domain names. So when we say DNS, that is actually a mapping of the IP addresses with the domain names, or mapping of the domain names with the IP addresses. So one of that is called the forward DNS, the other is called reverse DNS. Now, why do we have DNS? If you look a bit into the history, going way back in the late 1980s, early 1990s, it started out as a simple mapping that each host or each machine would have. There's a file, it's called host.txt file. The host names are introduced because, of course, names are easier to remember than numeric addresses. Names are easier to remember than addresses. If I tell you my name and my address, you would most likely remember my name rather than my mailing address, correct? So that is why we have DNS. Now let's say I need to access www.apnic.net. Before an application can send packets to my destination, basically, the IP address of that destination has to be known. So the function of DNS is to obtain the IP address given a domain name. That is what we know as a forward DNS. So in the example in the slides, the domain name svc00.apnic.net is actually mapped to an IP address 202.12.28.131. Now, if we talk about the reverse of that, the inverse procedure, let's say, for example, I know the IP address. What I don't know now is the corresponding domain name that stands for this. Okay, now this is where reverse DNS comes in. Reverse DNS is a mapping from number to name. So in our example, we have an IP address 202.12.28.131. Then it maps us to the domain name, which is svc00.apnic.net. Okay, so it's pretty simple. When you talk about reverse DNS, it's just basically the inverse of forward DNS. Now later on, as you will see, when you say forward DNS, you're actually using a specific type of record, which is the A record. Now with reverse DNS, we are now using a different type of record. This time around, it is called the pointer record. So that is one of the main differences. Now, if that is when you implement that using a DNS software such as Bind, or if you're using NLNet Labs let's say DNS software or Microsoft's DNS software, so they should be all the same. So that is basically the background that I wanted you to have. Now, why do we need reverse DNS? Now, a lot of domain zone administrators do not bother with reverse DNS. They thought that, well, once we have forward DNS, is it still necessary to have reverse DNS? Do we need that? Isn't it that in most cases, let's say, for example, when I'm browsing a website, what I would usually put is the name, the domain name. Let's say I want to access google.com. I would put in on my browser www.google.com, right? Now, why do I need reverse DNS when usually I just need a mapping from the name? Because that's what I remember, right? That's what the users remember. So map that to the corresponding IP address. That should be the main function of DNS. However, as you will see here, these are some of the features or some of the reasons why we really need reverse DNS as well. Some of the most common applications that rely heavily on reverse DNS are FTP, or SFTP, whichever you want to prefer, other forms of remote connections such as SSH, and also mail. So let's take FTP for example. This is a very easy example. Now, before a client can establish a connection to an FTP server, okay, many of these FTP servers are configured to check which domain is requesting access. Okay, so from that alone, now when you do the connection, we're using IP to IP. Now, what it needs to know is the domain that is requesting the access. if reverse delegation or reverse mapping is done correctly and it's set up correctly by the administrator, then the access domain may successfully trace back to the packet that is in its origin. You get the point? So once I do my mapping, if it's rightfully done, I'm using my IP address, it traces back to the domain name. Since it matches, therefore I know that it's actually originating from that particular domain. Now, hosts from address space which have not been reverse delegated may have the problem wherein they won't be allowed to access the FTP site if there is no reverse, if there's no DNS record for the client's host name. That application, the FTP application, will basically just the ignore the request. There will be what you call a lookup failure, okay, or it will time out, or it will result to a refused connection. So we call that service denial. So that is the first reason why we do DNS here. Okay, what else? Now, reverse DNS has been widely used by the network community. So if you're a network admin, network engineer, reverse DNS is very useful for diagnostics. Okay, it makes things a lot easier for us to read and interpret system logs, right? Because usually the logs would basically just contain IP addresses. Say if it's like on a packet level, you will see the source, destination addresses, and all that. Now, what I'm saying here is when you look at these logs and you all see the numbers, it might be a bit difficult, and then you have to do manual Whois checks, or let's say you have the IP address, you will try to find out who owns this IP address, right? You will do either a Whois lookup, okay, or a dig to find out the domain corresponding to that if they have reverse DNS. Now, most of the programs that we use as network admins, such as traceroute, these programs can do reverse lookups by itself. So prior to actually displaying the result, okay, it will do a reverse lookup. So what you actually see in the logs will be the domain rather than the IP addresses. Isn't that helpful? Like, it will be faster if you're troubleshooting something. It saves you an extra step in, say, trying to find that extra step, doing Whois lookups, finding the domain corresponding or the owner of that IP address, right? Once you have the domain, you would normally have an idea who is the owner, okay? What is the company name for that domain name? Yeah, because domain names are usually descriptive, right? So that's the second one, diagnostics. Another one that is very common nowadays is for spam identification, spam detection. In a way, having DNS entry for the server IP validates the IP address used by the mail server to send the email. Okay, do you get that? Like, if you have a DNS entry, and then the mail server will be validated that it actually is the mail server for that specific domain. It's called a forward confirmed reverse DNS, or a full circle reverse DNS. This technique is used in conjunction with other filter rules, right? If you are a systems administrator, you would know what I mean. Like, we have filter rules when we're identifying spam, where we will usually have a check whether does it have an attachment, does it use specific words, is it coming from these specific sources that may be dodgy. So we use penalty scores for all the emails that are coming. We mark them, okay? We give them particular scores depending on the content of that email. So when an email reaches a certain score that is set by the administrator, then the email will be marked as spam. It can either be automatically deleted, it can be stored in a spam folder, it might not reach the inbox of the recipient, right? So here, we don't want that if our emails are legitimate. So to avoid that, one of the scores that we use for spam penalty scores is whether they have the forward confirmed reverse DNS. So if you don't have that, you add an extra point, right? So to avoid your email to be considered as spam, it is best to have a properly delegated or a properly done reverse DNS. Okay, so that's number 3, spam identification. And also, the last one is mostly about the responsibilities. Now, with reverse DNS, we are mostly concerned with the IP addresses. When you get your IP blocks, you would either get that from APNIC, a regional internet registry, or from your service providers, which are also called the local internet registries. Okay. Now, when you get that block, there is a responsibility that is put in your hands to properly do reverse DNS. Now, when APNIC gives you an IP block, we automatically do reverse DNS for that block to you. Now, when you do delegate them downwards, then it's also your responsibility to do proper reverse delegation. Okay, so those are the main reasons. Those are the 4 main reasons that I can tell you why reverse DNS is necessary. All right, any questions so far? So we're basically just starting, so I guess I don't expect any questions at this point. Okay, so let's move on to the next one. I'll show you a diagram here. This is the DNS hierarchy. Okay, the DNS tree, as you can see here, follows a tree structure. It is very similar to how Unix or Linux operating systems have their file system hierarchy. Now here it starts out from the root. Okay, from the root it branches out to several different top-level domains or TLDs. Some of these TLDs you are very familiar of course. .net, .org, .com, those are generic top-level domains. You can also have CCTLDs. Okay, those are country code top-level domains that are specific for a certain country or a certain economy. Now there is one branch coming from the root which is concerned with the infrastructure. That is called ARPA. Okay, so these are for all the addresses, okay, and reverse delegations, okay, for anything that has to do with numbers, basically. Okay, all the rest is for domain names, but this particular branch are all for the numbers. So if you're doing your reverse DNS, then this is the branch that we are concerned of, right? So when we say, okay, let's take this for example. Similar to, let's say, I'll give you one example where for domain names first. How do we traverse the DNS tree using domain names? Let's say, for example, we want to go to whois.apnic.net. Remember, when we write down, when we write down a URL, we start with whois, okay, followed by the broader domain, which is the higher level or the parent domain, and then go on right to the root. So the way we traverse the DNS tree is actually going from bottom up, right? So in this case, where is our whois branch? This one. So that will be whois.apnic.net. Okay, so is that clear? So that's very easy, right? What I wanted to show is how we traverse the DNS tree, okay, to find out the fully qualified domain. This is how we got to our domain. Now, when we use reverse DNS, the idea is the same. So we start from the bottom. This time around, we're referring to numbers. So let's say, for example, you have a 202/8. Okay, you've been given, okay, that is a very large sum of IP address block. So let's say, for example, you have that at the early stages of the internet. So you've got a /8. So your branch is here, 202. Okay, so when you traverse that, your domain for this particular IP block will be 202.inadra.arpa. Okay, all this one in ADRA is actually inverse addresses. Okay, So that's where we put in all the IP blocks per /8. Notice that when we do those branches, it's still very classful. Okay, when we say classful, it is dependent on the octets per octets /24, /16, and /8. That's how we divide them on the DNS tree. Okay, so let's take another example here. Let's say you have a smaller block. 202.64.22/24. Okay, so let me try and write that down. Your block is 202.64.22.0/24. Okay, this is your block. Now, again, we start from the more specific, which is 22 here. Okay, and then going up 64, and then 202. Okay, from /24, /16, then /8, then going upwards, including inadra.arpa. You always write it that way so that it will be fully qualified domain name. So this will be the domain name for your block. So when you create your zone files, okay, remember if you're in forward DNS, you will create a zone file for your domain. Let's say for APNIC.net, you will create a zone file for that. You will create a zone file as well for your reverse DNS. Now this time the domain name for that specific zone will be this: 22.64.202.inadra.arpa. Okay, so don't forget that. The suffix will always be inadra.arpa. In order to properly reverse map 202.64.22.1, say for example you have one specific IP address, then it must become 1.22.64.202.inadra.arpa. Okay, so I hope you get that. I hope you understand that. Now, this is for IPv4. Did you notice? So how about IPv6? Where is the branch for IPv6? Is it still in ARPA? The answer, of course, is yes. It's still in ARPA. I told you before that ARPA is the only branch that deals with the infrastructure. Okay, but is it on inadra branch? So let's go to the next slide so that you can see this. Now, with IPv6, we're not using the inadra branch for all the IPv6 addresses. Instead, we have another branch, which is IP6. Okay, before, in the early stages, when they are still experimenting about this, it was actually using IP6.int. So there is another branch, a top-level domain called int, okay, which is used for IPv6. But that was during the experimental stages. Now this int top-level domain is no longer used. So if you're in your say DNS files, if you see that you're still using .int, then please remove that. It's actually now forwarded from int. Since that is removed, should be a branch under ARPA. So your IPv6 address will be your v6 address here .ip6.arpa. Okay, so is this clear? I hope you got that. Basically, there are two things. If you're using IPv4 addresses, it should be inadra.arpa. If you're using IPv6, okay, if you're doing reverse mapping for IPv6, then it will be ip6.arpa. Okay, it's pretty straightforward though. Have a look at this RFC 3152 that discusses more about it. Okay. Any questions? All right. Now, how do you create a reverse zone? Okay. Here, I am assuming that you somehow have an idea of how to do it in the forward zone. That's why I only put in, it should be the same as creating a forward zone file. Okay, when you're creating a forward zone file, you need yeah, well, you basically need to configure, of course, your name server's configuration file if you're using Bind. So depending on which name server software you're using. If you're using Bind, which is the most popular one that we use in the internet nowadays, then you will have to configure your named.conf file. Now there you will add in all your zones, okay, your forward zones, let's say your apnic.net zone, as well as your reverse zone. Okay, now the name for your reverse zone, as I mentioned earlier, will be something like this. Okay, so it's a zone and then codes 22.64.202.inadra.arpa code, and then you put in all the slaves for that in the configuration file. Now, in the zone file, you also need the same thing as what you need in a forward zone. You still have to create a SOA record. What is a SOA record? It is the start of authority. It will provide all the timing parameters, all the initial information that is needed to load that particular zone. It contains the zone name, it contains the domains, the name servers that is responsible or that is authoritative for that particular zone. It contains the email address of the administrator, okay, so that anything that has to do with that zone, an email can be sent to the email to the domain admin. At the same time, it also involves all the timing parameters, such as how do we when do we query the servers for any changes? Okay, when do we need to update? Or when will our zone expire? So those information. Now those are the same as how we do it in the forward zones. Okay, the SOA record is technically the same. At the same time, there is another type of record, the NS record, which should also be the same. NS record is for name servers. So basically, you are telling the zone that the name server that is authoritative for that particular zone is the name server that you specify in these resource record. Okay, so you will need at least 2 name servers. As a best practice, you always use 2 name servers. Next is, now you can add in all your records for the reverse zone. Now, as I've said, the main difference, I've mentioned this earlier, the main difference between a forward and a reverse zone is the use of a particular type of record. If you're doing forward zone, of course, you need an A record or a quad A record. A record is if you're mapping a domain name to an IPv4 address. Now, if you want IPv6 address this time, you will be using a quad A record. So mapping from a domain name going to an IPv6 address uses a quad A record. Okay, so you have A record, you have quad A record. So let's type that. Just so for everybody who were having a hard time following us, if you are not familiar with this before. So A record is for IPv4 address. Quad A record is for IPv6 address. You also have other types such as pointer records, which is for reverse mapping. You have a CNAME record. Okay, you can also have NS records, SOA records. So these are some of the types of resource records that we use. Now with, okay, that's gone. Okay, now with reverse domains, we are using pointer records or PTR records. So whether you're mapping from an IPv4 to an IPv6 address to a domain name, it doesn't matter. You always use a pointer record. Okay. Now you can use any software. You can use Bind. There are plenty of different DNS software out there, but Bind is the most popular one. It's open source. It's free domain for everyone. You can basically download it, install on your servers, and you will have DNS running in no time. So basically, when you install that, you'll also need to create the zone files. Okay, edit the name configuration file, and then add your records, add your mappings, which is the most essential part of it all, I think. Okay, so Something happened there. Okay. Let's go on to the next slide now. Now, these are the files that are involved when you're creating your zone files. Okay, you're creating your reverse zones. Same with same with forward zones, you need your forward zone files, okay? You always need that. Now, this is your reverse zones. Now, when you name your file, your zone file, now this is just a suggestion that I always give to people. You make it as descriptive as possible, okay? In this case, let's say for your forward zone, you have db.domain.net. Now, from the name itself, you would know that it is for the domain name domain.net. Now, if you have just one or two domains or zones, then it's very easy to identify which one's which. However, if you have plenty of domains, okay, let's say you're hosting, you're part of a hosting company. If you have a lot of that, then it might be a bit difficult to find out which one's which. So make it as descriptive as possible. Now, if you have, let's say, a software that does all of this, then it's pretty easy. But if you want to do it manually, then just make sure to follow what I told you about. Now, for reverse zone should be the same. Make it as descriptive as possible. Now, in this example, db.192.168.254, it's very easy to know, very easy to find out that this reverse zone file actually is for the block 192.168.254/24, right? Because it's right on the name itself. Now, you will still need your configuration files. As I've said, this example is for bind, so you have your named.conf. Also, you need your root hints, the hints file. Now, if you know how the DNS works, basically, if you have a recursive server, okay, when it queries for the mapping, let's say it queries for an IP address for a specific domain name, it would first go to the root, okay? Remember the DNS hierarchy tree that I showed you in the previous slide? So basically, it goes to the topmost first. Now, how does it know where to go? Now, that is specified in the root.hints file. So there you have the IP address of all the root servers around the world. So it will go to one of those, whichever is closest, and then it will query for the next, okay, next level domain which you can ask. So that is very important. Also, make sure that your root.hints file is updated. Recently, I think just around January, there were changes in the IP address that corresponds to, was it B or C? I can't remember on top of my head. But one of the root servers, I think it's b.rootserver.org, it changed IPv4 address. So make sure that you have them updated on your DNS, in your root.hints file as well. Now, when you see different files such as root.hints, db.cache, named.cache, named.db, they actually refer to the same thing. Okay, so you can use either one of these things. Okay, it's all up to you. It's just a different naming conventions. Some people prefer it to be named.cache. So when you go to rootservers.org, you can just easily download which file you want for the hints file, but basically the contents are the same. Okay, so any questions with that? Okay, so this is the SOA record. I'll just skip that one. This is the pointer record, which is what we are concerned about. Now again, it's a mapping from IP address going to domain name, right? So that's essential that you retain that in your mind. Now, if you want to put in the fully qualified domain, again, we will have to traverse from bottom going up. So let's say, for example, our IP address is 202.12.28.131. Then when we write it down as a resource record, we have to go backwards. So 131.28.12.202, and of course, make sure to add, okay, and trail in adra.arpa. Okay, that's necessary. And then the class is in for internet. Okay, the type is PTR for pointer. And then this is our R data, which contains the domain name. Now, the way to simplify it is if you already added the rest of the domain name into a file, a directive, or it is the name that you put in for your zone file, then it's not necessary to put the whole thing down. You can just simply use 131, and then automatically, since you don't have a dot here, that will automatically add or trail the remaining of the domain name to this number, or to this data. Okay, so this one is actually the same as the previous one. Any questions? Now let's make it a bit more difficult. With IPv4, it's very easy. It's very easy. So if you have 202.92.128.1, basically per octet, okay, per dotted decimal, you just reverse from right going to the left, right? Because it's inverse. Now, what happens if you have an IPv6 address? Let's say, for example, we have this IPv6 address, 3FFE8050:180:1, okay? Now, I assume that you have a basic idea of IPv6. Now, an IPv6 address contains how many hexadecimal digits? It should be 32 hexadecimal digits. Okay, so if you count this all the way from here going to here, there should be 32 of them. Okay, now if you see this double colon here, okay, this double colon actually stands for all the adjacent zeros. Okay, so actually if you count this whole thing, it will not be 32 because the rest is identified only by this double colon. Okay, so you need to understand that there are zeros in this field, okay? Because when you write down a pointer record for an IPv6 address, you have to write each and every one of those zeros. You can't use a double colon. You understand? So, similar to IPv4 reverse record, you will traverse from the rightmost going to the left. Here, we're not using dotted decimal, but we are using per hex. So whatever you find in an IPv6 address when it's written in its hexadecimal form, then you just use that. Okay, so it will be 1 dot few zeros here, okay, dot 2 dot 4 up to dot EFF3. Okay, so that's how you put it. And of course, you have to add the trailing branch, which is in this case IP6.ARPA. Okay, now can you tell me how many zeros can you find in this double colon before we continue with this example? Can anyone tell me how many zeros is actually being represented by the double colon? Anyone in the class? It's actually already in here. If you have a look at this, you will see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 zeros in between 1 and 2. Okay, 11 zeros in between this 1 here and this 2 here. Okay, so actually when you write down your pointer record, you have to write all the zeros. So 1 dot, all these zeros here, all 8 or 9 or 10 of them, and then dot 2, dot 4, dot 0, dot 0, okay, and then dot 0 again, dot 6, okay, dot 8, dot 1. Now there is something else that you see here. You have 42. Okay, this 42 here is actually 0042. That's why when you write it down, that will be 2400. Alright, I hope that's clear with everybody. Now you can either write that the whole thing, this one, this whole line, and then add 0.6 up to IP6.ARPA. That's also okay. That is the fully qualified domain name. However, you can use a $origin directive, okay, which makes it a lot easier for you, because once you have that, you don't have to repeat that again. So if you have a lot of entries to put in, like if you have a lot of hosts with different IPv6 address, and then your network address for this is actually 3FFE colon colon something up to 1860. Okay, this is, let's say, up to here is your network, and then you use this last say 2 fields to assign address to your let's say to your hosts. Then this network part, you can just use the $origin directive, okay, so that you don't have to write the whole thing down. You only need to add how many hexadecimal digits. Should just be 8 or 16 in this case. Okay, is this clear with everybody? Okay, I'm going to the next slide. This is a complete reverse zone example. Okay, you have your SOA record. Remember, we have a $origin in the previous slide, so you can also use that. This is your $origin. You can use that for V4, you can use that for V6. It's all up to you. Now you need your NS record. Again, your SOA record and your NS record is the same whether you're using forward or reverse DNS. Now your actual pointer record starts here. So 1 is a pointer record for this domain, gw.company.org, and also router.company.org. Now if you have plenty of these pointer records, there is actually an easy way in which you can basically add, let's say, give a pointer record for each of those IP address. So let's say, for example, in this case, from 65 to 127, so 192.168.1.65, let me repeat that, 192.168.1.65 up to 127, they are not, let's say, they're not assigned to certain customers yet, okay, or they're not assigned to certain hosts yet. So here, we just want to have a generic mapping. So let's say for .65, you're naming it as host65.company.org because it's not being assigned to anything else. We just want a complete naming. So you can use a generate statement. So $generate 65 to 127, and then you're replacing the $sign here. So pointer to host $.company.org. So it will automatically loop. So 65 will replace that with host65.company.org, 66 up to 127. You will just loop that until you reach the higher endpoint, which is 127. Okay, is this clear? So alright, so that's pretty much how you implement reverse DNS on your zone file. So if you haven't done it yet, then it's fairly easy to do. Just follow those instructions. Just create your zone files as to how you do it with forward zones. Now, one thing that you need to know, of course, is that when we do reverse delegation, I've mentioned this before, it is still using classful. It's still very classful. So have a look at RFC 2317 actually. This actually refers to if you're doing less than /24 delegations, but we'll come to that later. So when I say classful, we are tied with when only delegating either /24, /16, or /8. We won't concern ourselves with /8 because actually right now no one's really delegating any /8s anymore. So let's just start with /24. Let's say you have a /24 block. So in your name server, you will create a zone file per /24. Okay, for that /24 block. Let's say you have 192.168.1.0/24. Then you will have one reverse zone file for that /24 block. Okay, is that clear? So I think it's very easy. Again, you need at least 2 name servers. Okay, that's the same if you're using reverse or forward zones. You need at least 2 name servers. Now, let's say you got this block from APNIC. They gave you a /24 block. It is now necessary for you to have the 2 name servers because you will specify that in the reverse delegation form when you request for that. Okay, so 2 name servers is necessary. Now, what if you have a /16 delegation? Okay, now this is a very big block. Now, we're not really using this as much anymore, but ideally when you have a /16, the delegation is the same as with /24. Okay, so again, since we're very classful, we are tying ourselves into per octets. So the /16 delegation is pretty much the same as in /24 delegation. The whole block will be assigned to you. The whole block will be delegated to you. You only need to create one zone file for that /16 block. Okay. There are a few other requirements, such as APNIC needs you to have a secondary zone and all that, but I will leave that for now. But basically, the idea that I wanted you to get here is like when you're doing /16, you will only have one /16 zone file for that block. Now, the problem is most people get somewhere in between the /16 and the /24, right? You may have a /19 block from APNIC. You may have gotten a /22 or a /17, a /18, all of that. Now, how do we make delegations for that? Now, let's say I have a /22. How many /24 blocks do I have in a /22? The answer is 4. There are 4 /24 blocks in a /22. Now, when I create my zone files, I have to do 4 /24 blocks. Okay, I cannot make one /22 block for my reverse delegation. Again, it is based on the /24 size. So if I have a /22, I have to create 4 zone files, okay, for each /24 block within my /22 block. Okay, everybody got that? So that's basically how you did. If you have, let's say, a larger block, you have a /19 block, then you will have more /24 blocks in your zone files. Okay, so you will create each zone file in your named.conf will only be a /24. Now, what if I'm delegating somewhere that is lower or smaller than a /24? Now, this is where I would like you to refer to RFC 2317. It tells you how to do classless in ADRA.ARPA. So how are you going to do it on your, let's say, on the machine that's doing the delegation? Okay, so I'm not sure if I have explained it already. I have done it in the DNS class, but I'm not sure if I've done it in here. So when we say delegation, we are assigning or we are transferring the authority for a particular subset of our block to another group or another organization. So in forward DNS, we do that when we are delegating subdomains. In reverse DNS, we are also doing that if we are assigning a sub-block of our entire IP range. Okay, so let's say if you got an IP block from APNIC, APNIC is actually doing reverse delegation to you. Now, if you are, say you're a service provider, you have a lot of customers, and you're giving your customers, let's say, a /22 block, then this time you're doing reverse delegation to your customers. There is something that you have to do on your servers, okay? Then also your clients, your customers also has to do something on their servers to address the delegation part, okay? So this is what I'm referring here. If you, let's say you're just delegating a small block, you have a small customer, you're giving, let's say, a /27, okay? How do you do delegation with that? So that is answered in RFC 2317. Go have a look at that. It might be hard for me to explain it here. That's why I'm referring to you to the RFC. But basically, you will add a record, an NS record, go from your zone file, going to the so that it will be referred to the it's like a glue record in forward zone. So it will be referred to the name server of your customer. Okay. So I hope that's clear enough for everyone. If you want me to explain that further, I think I will leave that for either a later session, or if you want more explanation, I can do that via email, okay? Or send me an email if you want me to explain how it is done. I've had that problem before, so I'm sure many of you who are also zone administrators may have encountered that issue where you need to delegate a very small block, /27, a /29 to your customers. Now, how do we do that? Okay, I'll explain that to you. If you want to, just send me an email. Now, here we're reaching the end of our class. Here, I am just pointing out some of the responsibilities that you have as let's say once you have your IP block. Okay, it is actually a responsibility that you have to make sure that it is properly delegated. Okay, so and once you got the IP block from APNIC will automatically do a reverse delegation for that address block to you. Okay, once your request has been processed, we will do the reverse delegation. We'll just need two IP addresses, two name servers from you. Okay, the IP addresses of your name servers, and then we will work from there. Now, in your case, from your organization's point of view, you have to be familiar with the APNIC procedures. And once you receive your IP block, make sure that you have the proper reverse mapping for that. Okay, we don't want I've told you the main issues that can happen if you don't do reverse DNS or reverse mapping. Okay, we don't want that to happen. So make sure that all the blocks that are assigned to you have proper reverse mapping, or if you've assigned them to your customers, that they are also properly reverse delegated. Okay, it is your responsibility to maintain your name servers. I think that is pretty straightforward as well. And we don't want pollution of the DNS. Okay, we don't want blocks that are hanging that don't have proper delegation. That is what we mean by this last line. We want to minimize the pollution of DNS as much as possible. Okay, so now when you do reverse delegation procedures, these are the steps that you may want to follow. Okay, the easiest way is, let's say, for some of you who are working, let's say for an enterprise or a big academic institution, you may have gotten a /20 block somewhere that's quite big before the exhaustion phase. Say you have a /20 block. You have different regional offices. Okay, now you want to delegate some parts of your IP block to those regional offices. Now, how do you do delegation for that? Because you requested the block from APNIC. Now let's say you're just giving /24 for each to make it easier. Okay, from your /20 block, you are giving /24 blocks to your regional offices. Okay, now this /20 block is you got that from APNIC. Now, when you need to update the delegation to another regional office, okay, they have their own domain name, their own name server, right? So you go to My APNIC. So you basically log into your My APNIC account. You provide the name server. Okay, you search for you need to provide for the IP block, the /24 block, and then provide the name servers. Provide the maintainer object, okay, the maintainer password for that object as well, and then just click send, and it will be processed as soon as possible. Okay, so if you have any problem with that, if you have any queries, we can always help you with that. Just contact our help desk at helpdesk@apnic.net. You can actually also give them a call or send a quick chat to them using our website. So it's fairly simple. It's I'd say once you have access to My APNIC, everything can be done from there. So it will be a very easy process for you to do. Okay, so when do we need this? Again, if you want to delegate a smaller block, okay, to a customer. Okay, that is if the minimum is /24. Now, if it is less than /24, then that is not done through My APNIC at all. That is done using from your name servers. I've referred you to the RFC earlier on, so have a look at that RFC on how you can do it. Okay, so any questions? This is the form where you do or add your reverse DNS delegation. Again, it needs your address range. It also needs your name servers. You need at least 2 name servers here, and your maintainer and the maintainer password. Okay. I've got a few people who are just trying to join us. Actually, we are almost ending the class. hopefully, for those of you who just joined in, or maybe some of you have just disconnected, I don't know. If you just joined in, I'll probably just give you this set of slides, and then I'll leave you to look around and study the slides. And then if you have any questions, just let me know. Send me an email and send me a chat and all that. Now, where do we find the objects for the reverse zones? This can be found in the Whois database. So all the entries for the reverse zone can be found in the Whois database. Now, this is very important. This is accessed by all the network admins. Now, you have this domain. This is for 202.12.28/24. This is your reverse zone. Now, you have your admin and technical contacts here. Okay, such that if anything goes wrong with the IP address that is currently given to you, these are the people who are responsible for that. They have your details here. Once they click your nick handle here, they will have your email address or whatever information that you've provided. Now here is the name servers, the 3 name servers this time. The minimum is 2, but you are free to add more name servers as you wish. So these are the 3 name servers that does reverse DNS for this IP block. Okay. Now these are just logging fields, like where was the last time it was changed, and then here you have your maintainer. So if you want to change anything with a specific block, it has to be using this particular maintainer. In this case, main APNIC-AP, and then you must know the password for that. Okay, so that concludes our reverse DNS. Now, this has got to do a lot of administrative things for you. Like if you want to do proper reverse delegation, you may have to go through APNIC, or you may have to go consult with your upstream if you're, like, say, if you're an end user, and for that to happen. So I think I'll just end there. It's 3:30. We're just about on time. That's very good for me. Now, if you have questions, can you please type it on the chat? We'll try to answer them. I always encourage people to ask questions, to be as interactive as possible, because we have a few people in the class, so it's not just me who can answer your questions. If there is anyone else who's here, then they can pretty much give feedback as well. So if you have questions, please type it on the chat. Someone raised his hand. If I allow this will actually give audio to you, so I'm just gonna cross it out. Your questions, can you please type it on the chat? Someone asked if it is a general practice to use the generate statement. Okay, because I actually don't know, to be honest with you. I'm not sure whether it is widely done nowadays, because most of the big providers, most of the big DNS providers basically have their own software. They use their own software to do this. Now, the generate statement is used when you are using, say, DNS bind. But DNS bind is very popular. So I would say I don't have figures, I don't have statistics. These are only based on the things that we are actually also implementing ourselves, and also based on the few DNS admins that I usually talk to. So I would say probably not generally, but it is a good practice. Okay, we don't want to leave some of your blocks without proper reverse mapping, since you're not it's not delegated yet to someone else, or it's not used for a particular domain yet, so might as well use a generate statement. That's what I think. I hope that answers your question. Sorry, I can't really pronounce your name, as Gopinath. Hopefully that answers your questions. Any other questions, everyone? Okay, so If you're still thinking of questions to ask, I'll just quickly type in the survey link. So all the rest can also go through that link. Actually, it's on the slide here, but I am going to write it down on the chat so that all you have to do is click on the link. Now, this is the feedback form. If you can please fill it up for us, that will be very helpful. We want to get your feedback as much as possible so we know whether there are things that we have missed that you really want to know about this particular topic, or if there are other topics that you want us to do probably in the near future. We are introducing a lot of courses every now and then, so watch out for that. Go to our website at apnic.net/training. Have a look around. If there are topics that are also interesting for you, please feel free to register for those sessions. Now, this is actually part of a series. This is the second of a 3-part series. The third is on DNS security. So if you are a systems admin, I would say that it will also be helpful for you to attend that session. So I'm not sure whether, I don't have the schedules with me at the moment, but have a look at our website. When is the next time we are going to do that particular session? So, and if anyone also want to have a copy of the slide handouts, then you can have that after you fill out the survey. So after the survey, you will automatically be redirected to our FTP page where you can download these slides in PDF format. So I think it's better if you can have a copy of those slides and then review it, have a look at it. And then if you have any further questions, then send me an email. I'll be very glad to help you. I was a DNS administrator once, and although the initial setup is actually kind of easy, okay, the reverse delegation part may be a bit tricky, especially if you're doing it say smaller than /24. So if you have questions on that, I would be very glad to help you out. Okay, so no one is typing any questions, so I think I will just end there. Thank you very much, everyone. If you have any questions with regards to your resources, with regards to doing reverse delegation, chat with our help desk people. They are very good. They can actually also speak multiple languages, so if you're more comfortable in your local language, then it's also good to talk to them. And that's it. I'd like to thank you, everyone. Thank you for your time, for your attention. Thank you for registering with us. I hope to see you again next time as we do more e-learning topics. Okay? See ya and have a great day. Bye-bye.